Okay, that's as good as it's going to get this late at night. That is my destruction of Dave Brubeck's Kathy's Waltz. It probably sounds better on this CD. Anyways, today's class, this is an outline of today's class. So I'm going to start off with a review of muscle fiber typing. Then I'm going to go over the cross-bridge cycle. Again, a review. Muscle contraction, and I'm going to go through steps in muscle contraction in detail. So that's the main part of this lecture. So multiple choice question for you here. Fast twitch A fibers. A have a greater endurance than slow twitch fibers. B have a faster relaxation time than fast twitch B fibers. C have a shorter time to peak tension compared to slow twitch fibers, or all of the above. The answer here is C. They have a shorter time to peak tension compared to slow twitch fibers. So they have a faster contraction time compared to slow twitch fibers. Multiple choice question 2, which fiber has been classified based on metabolic properties? So the answer here would be A, your fast oxidative glycolytic fiber. So that's based on oxidative and glycolytic enzymes. Type 2A fiber is probably the same type of fiber, but this fiber type classification is based on your myosin ATPase activity or your myosin heavy chain. Fast fatigue resistant is based on twitch contractile properties. So that's when you deliver an electrical stimulus to a muscle repeatedly, and in this case it has a fast contraction time, but it is also fatigue resistant, so the force doesn't drop off that much with repeated muscle contractions. So the best answer here would be A, your fast oxidative glycolytic. Which of the following would lead to muscle contraction? So binding of calcium to troponin, pumping of calcium back into the sarcoplasmic reticulum, binding of ATP to the actin cross-bridge cycle, cross-bridge, or tropomyosin covering the myosin binding site on actin. Your correct answer here would be A, binding of calcium to troponin. So that would lift the tropomyosin off of actin and allow myosin to bind with your actin. When ADP and inorganic phosphate are bound to the myosin, myosin forms strong cross bridges with actin. True or false? This answer is false. So if you go through the cross bridge cycle, this is just a review. You can see that down here you have ATP associated with the myosin head. That has to be broken down to activate myosin. So that releases energy to activate myosin. You get calcium binding to troponin. That lifts the tropomyosin off the actin, allows myosin to form cross bridges with actin. If you still have these breakdown products from ATPs, or adenosine diphosphate and inorganic phosphate, then that prevents a strong cross bridge between the myosin and the actin, and you have weak force production. Those have to be kicked out for your strong cross bridge to be formed. So this answer is false, because when that ADP and inorganic phosphate are bound in this stage of the cross bridge cycle, it prevents a strong cross bridge from being formed, and you have weak force production. That's all I have for the first part. I'm going to continue with the second part with conduction of the action potential from axon to muscle fiber.